All right, today's lesson we're going to go over activity 2.2 using additive inverses to combine linear systems. I originally have us plan going through about 2.3. We'll see how I do with this. If I feel it's a little too much, then we'll probably just stay on this. So it says in the system of equations from the previous activity, one of the variables in both equations has coefficients that are additive inverses. What if a system doesn't have variables that are additive inverses? Let's use the strategy of linear combinations to solve other systems. We're going to look at the work example and answer problem 1 with it. Consider the system of equations. 7x plus 2y equals 24. 4x plus 7y equals 15. If we look at this, we have multiply the second equation by a constant that results in coefficients that are additive inverses for one of the variables. So what they ended up doing, if we look here, we have our y's. It'll be easier to make our additive inverses. So they're going to times the whole problem by -2 because this is a positive to make this a -2 so you can eliminate them. So after they multiplied each part, so the 4x plus y as well as the 15, they came out with a -8x because 2 times 4x, -2 times 4x gives you -8, and -2 times positive y gives you -2, 2 times 15 gives you -30. So this problem right here in the black box is this problem right up here. They eliminated by taking the two y's out, and then they added 7x plus -8, which gives you a -x, and then 24 plus -30, which gives you -6. They divide -1 on each side because if you look at this part right here, you would have to divide, this is essentially what is a -1x, so you divide -1 on each side to get rid of the negative number, which will leave you as x equals +6. If we look at the next one, they're asking, now we have to substitute the value for x into one of the equations to determine the value for y. So they're taking this top one, and they're substituting the 6 in for the x. 7 times 6 gives you 42. 2 plus 2y equals 24. You subtract 42 on each side, and there's my 42 subtracting. Leaves us -18. 2y equals -18. Divide by 2 gives us an overall y equals 9. So our equation, as we've talked about in the past, you have to set up as x comma y would be 6, -9. That would be our answer to that problem there. If we look at number 1, it says in the worked example, only one equation needs to be written to solve using the linear combinations method and y. For this one, you only need to multiply the equation. So multiply 4x plus y equals 15 by -2 to make the y terms as additive inverses. Once again, that's to get them to eliminate. Okay, so that's how that problem is solved there. Now, let's go on to part 2 here and work through this. So it says, now let's consider a system where both equations need to be rewritten. So both need to be done. They multiply each equation by a constant that results in coefficients that are additive inverses for one of the variables. So if we look at this top one here, they're looking at this and seeing that they're going to make the y's as the additive inverses in these two problems up here. So they have 2y and a 3y. They're going to times the top by a 3, and they're going to times the bottom by -2. Remember, you have to do the opposite. So if it's positive, you have to make it a negative. When they do this, they have 3 times 4x, 3 times 2y, and 3 times 3. -2 times 5x, -2 times 3y, and -2 times 4. Which leaves you this equation right here in the black box. Now, it's going to eliminate the 6 y's so that you can solve these. So now we're looking at number 2. It says determine solutions shown for the second work example. So like I said, we're going to just rewrite it here. I'm going to zoom in so you have a little more room to see. 12x plus 6y equals 9. Negative 10x minus 6 equals negative 8. So now we're adding these. As we said, those eliminate. 12x plus negative 10x will leave us with 2x equals negative 9 plus, positive 9 plus negative 8 will leave us with 1. Divide by 2 on each side means our x is going to be 1/2. We substitute 1/2 in for one of the problems. So let's look at the top one of 4 parentheses x. I'm going to put x as 1/2 plus 2y equals 3. We know 1/2 of 4 is just 2 plus 2y equals 3 minus 2 on each side. Now we're left with 2y equals 1. Divide by 2. And now we're at y equals 1/2. And there's our answer to this problem. So if the variables cannot be matched, so we cannot take, like say the 3y was 4y, we can times the top one only by 2. If we can't, we have to times both problems by whatever variable we want to eliminate. So if we're trying to eliminate the y, we have to times them by the same number. So 3 on the top, 2 on the bottom. Number 3, we're going to answer 3 and 4. And I'm going to call that where we're going to stop for today because we're not going to do number 5. I'm going to skip that for now and call this a day. Number 3, how could you have solved this system of creating x values that are additive inverses? Essentially how you can answer this is we have to multiply. So multiply equations by the number in front of y to create additive inverse to solve equation. Now, what I'm going to have you guys do is you're going to need to solve 4C. That you will do on your own, as well as 4B, and I will show you how to do 4A. Alright, so 4A, actually, I lied. I'm going to do B, and you guys will do 4A and 4C, so you get some practice work on each of those. So we look at B. We can see that our additive inverses of our, let's look at the y's, is a 3 and a 2. We cannot times 1 and get the correct answer. We need to times both. So the top one, we'll times it by 3. So 3 times x plus, I'm sorry, not 3. We'll times it by 2 in the top. 2 parentheses x plus 3y equals 15 times 2. The bottom, we'll solve this out and then we'll do the bottom one. So 2 times x gives us 2x. 2 times 3y gives us 6y. And then 15 times 2 gives us 30. Now the bottom one, we have to set 5x plus 2y and times that by 3 because the top number had a 3, so we can cancel these out. Equals 7 times 3. 3 times 5x gives us 15x. 3 times 2y gives us 6y. I'm sorry, I'm writing that wrong. And then 7 times 3 gives us 21. So we rewrite this equation over here, 15x plus 6y. I'm sorry, I did this all wrong. erase over here, because these are positive numbers, we have to do negative. We're going to times this bottom one by -3. I am sorry. So just erase that and we'll restart. The reason for that is because this is a positive and this is a positive, we have to make one of them a negative. So 3 times 5x gives us -15x. -3 times 2y gives us -6y. And 7 times -3 gives us -21. So we rewrite this now this way, which makes a lot more sense. -6y equals -21. When we eliminate these things, we do 2x minus 15x, which will give us -13x. 6y minus 6y gives us 0. And then 30 minus 21 ends up giving us 9. Divide by -13 to get x by itself. And now we're left with x equals 9 over -13. So parentheses, we go -9 over 13 for our x value. And then for our b value, or our y value, we have to substitute that in. So using your fancy dancy calculator, we're going to type it in the top one. So we're going to go, or bottom one, 5 times -9 over 13 plus 2y equals 7. You type that in your calculator, and I'm going to pull it up on my phone right now. 5 times, actually I'm going to do 9 divided by 13 first, times that by 5 is going to give me -3.46 plus 2y equals 7. We add this on each side, cancels, add over here, will leave us with 2y equals 10.46. And take 10.46 divided by 2 is going to give us y equals 5.23. So then our y is just 5.23. If you get them both in decimals or fraction, that's fine with me. Now, you will have to work on A and C on your own. C, you will have to, I'm going to write a note here for you. You will, let me erase this so it looks a lot cleaner for you. You will multiply top and bottom to solve the equation. And then the top one, it already sets it. You may have to multiply one by a negative because both of these are positive. Work on that. Submit this so I can see how you do, and I will give you guys feedback. If you have any questions, do not hesitate to email me.